I am Anil Kumar. Welcome to my series on equations reducible to quadratic form. In this video, we are going to take the 6 examples. These are all radical equations, but you could do substitution and adopt few techniques to solve them as quadratic equations. So that's the whole idea. We do have solutions for trigonometric, exponential and logarithmic equations in quadratic form also, but here we'll only concentrate on radical equations. Let's take them one by one and see how to solve them. We need to solve x cube minus 13 x to the power of 3 over 2 plus 40 equals to 0. Now what we notice here is that this is cube and this is square root cube, right? So that is what you notice. So if I make a substitution that let some variable p equal to this portion, which is x to the power of 3 over 2, in that case p square will become square of this, right? So it will be x to the power of 3 over 2 whole square, which is same as x cube. So that is the substitution which we are going to do. So I'm going to replace x cube with p square. So we get p square minus 13p plus 40 equal to 0. Now this is a simple quadratic equation which we can solve by factoring. Correct? So let us try to factor this and solve. We're looking for product of two numbers to be 40, sum 13 minus. So we could take two negative numbers, 8 and 5. 8 times 5 is 40, and when you add you get 13. So we'll split 13 as minus 8p minus 5p plus 40 equals to 0. Now let's group and factor. We can group p from the first two terms, getting p minus 8, and here we could factor minus 5. We get p minus 8 equals to 0. Now p minus 8 is a common factor, and we get p minus 5 as the other factor. Now applying the rule of zero productive, two numbers when multiplied gives you 0 when either one of them is 0 or both are 0, right? So that gives you two solutions here, one being p equals to 8 and the other p equals to 5, correct? Now we can substitute what p is and then find the value of x. That's the whole idea, right? So we know p is 8, but p is x to the power of 3 over 2. That means x to the power of 3 over 2 is 8. P equals to 5 means x to the power of 3 over 2 is 5, correct? So substituting back, we get the value of x. So let's get the answer here. We are saying x to the power of 3 over 2 is 8. That means x is equals to 8 to the power of 2 over 3. That means cube root of 8 and then square, right? So basically we want to say what is the cube root of 8 and then you square it. This is what it means, right? So cube root of 8 is 2. So we get 2 square, which is 4. So one of the solutions is x equals to 4. Let's find the other solution. The other solution is, we are saying x to the power of 3 over 2 is 5. So from here, we can say x is 5 to the power of 2 over 3, correct? So that we could write as such. So the answer here is that x is equal to 4 and x could be 5 to the power of 2 over 3, correct? So I hope that makes sense. Now let's move on and solve the next question. Now the equation before us is 2x to the power of 2 over 3 minus 9 times x to the power of 1 over 3 plus 4 equals to 0. Now here we could substitute p as equal to x to the power of 1 over 3, right? So in that case, p square will be x to the power of 2 over 3. So that is the substitution we are going to make. So we could rewrite our equation as 2 times p square minus 9p plus 4 equals to 0. Now we're looking for product of 8 and sum of minus 9. So we could write minus 9 as minus p minus 8p, right? Plus 4 equals to 0. Factoring p from the first two terms, we get 2p minus 1, and let's factor minus 4, we get 2p minus 1 equals to 0. Now 2p minus 1 is a common factor. We get p minus 4 equals to 0. That gives us p equals to half, or p equals to 4, correct? Now we can find what x is. So I hope you got the strategy. So that is how you could solve all such questions, correct? So when we say p equals to half, we are saying x to the power of 1 over 3 is half. So x is cube of half, correct? Which is 1 over 8. So that's the value, one of the values of x, right? The other one will substitute 4 this time. So we know p is equals to 4. That means the cube root of x is 4. So x is 4 cube, which is equal to 64, correct? So we get two answers. One is 1 over 8. The other one is 64. Clear? So that is how we should be doing. So let's take up the next question now. Now the question is 2x minus 1 to the power of 2 over 3 minus x to the power of 1 over 3 equals to 0. Now here both are cube roots. What we can do is we can take one term to the other side and cube both sides. So we're going to solve it like this. 2x minus 1 to the power of 2 over 3 will be equal to x to the power of 1 over 3, correct? Now let us cube both sides. So we get 2x minus 1 whole square equals to x. Now let's expand. So we get 4x square minus 2ab means 4x plus 1 equals to x. Bring them all together. We have 4x square minus 5x plus 1 equals to 0. Now that is a quadratic equation. We're looking for product of 4 and sum of minus 5 to solve this equation. So that is 4 times 1. So we could write this as 4x square minus 4x minus x plus 1 equals to 0. Factoring 4x, we get x minus 1, and here minus x minus 1 equals to 0. Now x minus 1 is a common factor, so we get 4x minus 1 equals to 0. That means x equals to 1 or x equals to 1 by 4. So that becomes the answer. Is that clear? So that is how we could actually solve this equation. Now we'll take equations having square roots. Square root x plus 2 equals to square root of 4 plus 7 square root x. So let us square both sides. What do we get? Oh, we get, when you square both sides, what I'm trying to say is like this. A plus b whole square formula will be applied, correct? Which is a square plus 2ab plus b square, right? So square of square root x is x plus twice 2 square root will give us 4 square root x. Square of 2 is 4. And here we'll get 4 plus 7 square root x, correct? Now let's bring the square root terms together and then solve for then again we'll square, right? So what we get at this stage is we have x plus 4. We'll bring minus 4 here, okay, equals to 7 square root x, and we'll take 4 square root x on this side. So rearrange to solve for square root x. So that gives you x equals to 7 minus 4 is 3 square root x, correct? Now we can bring these things together. Now, it will be a mistake if we cancel out square root x. You lose one of the answers. So at this stage, what we should do is, we should rearrange it. So we could get x minus 3 square root x equals to 0. Now we can take square root x common. So we get square root x minus 3 equals to 0. So I hope you understand that step, right? It's kind of very critical. If you cancel square root x, then you lose one of the answers, right? Now here we have two solutions. One is square root x equals to 0. That gives you x equals to 0. And the second one is square root x equals to 3. And that gives you x equals to 3 square, which is 9, correct? Square root of 9 is 3. So we get two answers. Now it is always a good idea to check your answers. So I like you to substitute x equals to 0 and check. So if you do it on left side, we get 0 plus 2. And on the right side, we get square root of 4 plus 7 times 0. It is just, so that both sides are 2 equals to 2, correct? So that works. You could substitute 9 now. So substituting 9, that is to say, square root 9 plus 2 is 3 plus 2, 5. And here, if I substitute 9, I get 4 plus 7 times square root of 9, which means square root of 4 plus 7 times square root of 9 is 3. 4 plus 21, which is 25 square root, is also equal to 5. So that also works, correct? Now, so this also works. 25 square root is 5. So we get two answers here. One answer is x equals to 0, and the other one is x equals to 9, right? So these are the two answers for the radical equation. But it's kind of important to test your result. We found that both work. Now you could also see that in our example, x should be greater than or equal to 0, and both are satisfying the given condition. So it also works. Perfect. Now let's take up the last two examples. Let us solve the radical equation x over square root of 2 plus x plus square root of 2 plus x equals to 0. Now here, denominator cannot be 0. Within square root, we should always have positive number. So x should be greater than minus 2. Right? Only then we can have valid solution. So to solve this, we'll multiply, or let's take a common factor, correct? So we could do a common factor of square root of 2 plus x, and what we get here is x plus 2 plus x equals to 0, right? So that gives you 2 plus 2x equals to 0, right? So 2 plus 2x equals to 0. So you can say 2x equals to minus 2, or x is equals to minus 1. So we get x equals to minus 1 as our solution. So that is the answer. So I hope the steps are absolutely clear. Let's move on and take up the next question. Here is a very interesting question to solve. We need to solve for square root of 2. Within the square root, we again have square root of 7x plus 2 equals to square root of 3x plus 2. So in the first step, let us square both sides. So we'll get rid of the square root. So what we get here is 2 square root of 7x plus 2 equals to 3x plus 2. Now let us square again, right? So let's square again. Both sides. So in that case, we get 4 times 7x plus 2 equals to, square of this will be 9x square plus 2ab. That means 6 times 2, 12x plus 4. Now we can solve as a quadratic equation. We get 28x plus 8 equals to 9x square plus 12x plus 4. Bringing all the terms to the right side, we get 9x square plus 12x minus 28x plus 4 minus 8. That gives you 9x squared, and that is how much? So from 28, let's take away 12, so we get 16, and here we get minus 4, right? So that becomes our 16x. So that becomes the quadratic equation to solve, which we are now looking for product of 36, right? So we're looking for two numbers whose product is 36 and the sum is 16. So what could those numbers be? 18 and 2 can work for us, right? So we could write this as 9x squared minus 18x plus 2x minus 4, correct? Now let's take this equation to the right side and solve. So we get 0 equals to, we can take 9x common, we get x minus 2, and here we can take 2 common, we get x minus 2 as a common factor, multiplying by 9x plus 2. So that gives you two solutions. One is x equals to 2, the other one is x equals to minus 2 over 9. Perfect. So these are the two solutions for the given equation. Now you can actually check the solution, so I'll leave that for you. Check solution. Okay. Now one way is definitely, whenever you have these equations, you have to look what the x value should be. So this gives you that x should be greater than minus 2 over 3. And here it should be greater than minus 2 over 7. Right? So we have to get x greater than or equal to minus 2 over 3. Correct? Since minus 2 over 9 is much greater than minus 2 over 3, it should satisfy. Correct? Now you can see, if you draw a number line, for example, right? So let's say this is 0. And if minus 2 over 3 is somewhere here, let's say this is 1 unit, right? So if you divide it into 3 equal parts, then minus 2 over 3 is somewhere here. So we want solution in this interval. Minus 2 over 9 is much, much closer. That means we have to divide it into 9 parts, kind of, right? And then it is somewhere here. So it is much, much closer to 0. It is far greater than minus 2 over 3. So that should work, correct? But I like you still to check by substituting the values and verifying that left side is equal to right side. So I hope you have learned the technique of solving equations which could be reduced to quadratic equations. So in this particular video, we did all 6 of these examples. I hope you find them interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.